Oswald viscometer basically measures the time of flow for a certain volume of liquid to pass through the capillary. It measures relative viscosity, that is, the viscosity in comparison to a standard fluid, which is water. The driving force of flow is gravity. The volume of the bulbs are constant. The upper bulb will have same volume of water and the sample, but the weight may be different. If the density is higher, driving force will be higher. Hence, it's important to measure the density of the test liquid and water. So, the viscosity of water is available from the database at different temperature. It displays the viscosity of water that is known. The density of water is also known because there are standard databases. The sample liquid is the unknown. Its density can be easily measured using a specific gravity bottle, that is an experimental data. The time of flow for both is determined by the viscometer. The equation shows the relationship of viscosity with density and time of flow. Hence, out of the 6 items, we can get 2 from standard databases, that is viscosity of water and density of water at a particular temperature, and others, the density of sample and time of flow for both water and sample comes from the observation. When you put all these values into the equation, we get the unknown viscosity. Hope you understood the concept.
This is a viscometer, the one which will be used for measuring the time of flow. Now you are asking me what flow. You see there are two bulbs, nothing special here. The smaller one and slightly bigger one. So first we have to fill up this with the fluid. Then using suction at the top end, we have to draw the fluid up. The main thing that we have to measure is the time required for the fluid to flow from this point to this point. There are 2 distinct marks. Now, 2 things we have to be very careful. One, if the level becomes equal, suppose the liquid has come up to this level and here this level is there. It has reached this level. Because as it flows down, the level goes up here. So the whole flow will be stopped. So right from the beginning, we have to maintain a difference of the level. These 2 bulbs, even if full, then the level cannot be maintained properly. Better is that you fill this much, draw it up to the upper level. When it comes down, again, this much, it will be refilled up to that level. In that way, we will be able to maintain an equal pressure head. The difficult part is drawing the liquid. I have to place this here, I have to push it a little more so that it goes inside. It takes a bit of force. So as I squeeze it powerfully, the air is expelled and that air pushes the water beneath and we'll see the thing moving, and if the force is too much, it will come out, part of the water. But as soon as you just release the force, there the liquid will start going on its moving out. It will take a little bit of time as it fills, because of all the places when it passes through the capillary, the movement is bound to be slow. It comes slowly, it will go up also slowly. So slowly we'll be seeing it's going up.
Then measure the time of flow for water. Repeat the experiment 3 times and note down the average time required for the water to flow through the capillary. Next, the same experiment will be done with the test liquid, and then nothing else, you have to put the values into the equation. One thing you have to do extra, that is measuring the density of the test liquid too, and placing all these values into the equation will give you the viscosity of the test liquid provided it's Newtonian.